Alright, today we're going to look at what we need to do for our lab report for Lab 5, our Oxygen Uptake and Efficiency Lab. So we need to find on the web page under lab material, we need to find the lab report guidelines and the data. And let's go to the lab report guidelines first. So as always, you need to state the purpose of the lab. And the purpose of this lab is to look at oxygen consumption at rest, at varying workloads of submax. So it's not a maximal test, it's a submax test, and during recovery. Under results, we need to go step by step here. So again, it's super important that you guys are looking at this worksheet, not just going based on what you're going to verbally hear me say, but also look through to make sure I haven't missed something, okay? So with the data provided, which we'll open in a second, we need to calculate mean and standard deviation for oxygen uptake in the liters per minute category for all 3 workloads. So I know in lab we did 2 workloads, but when we're looking at the data, we're going to look at 3 workloads, and this is all data that we're giving you. So we have a 0.5, a 1, and a 2 kp. And you're going to present this data in the figures. So in the directions below, we'll analyze or graph that data. But let's first move to our data. And let's start getting our means and standard deviations for the varying degrees of exercise that our participants did. So we have the 0.5, and you can see here I have my means and my standard deviation for each minute. And then I'm just going to walk you guys through this. I know you know how to do it, but in case you forget, the super cool fast way to do it, I'm going to review it here. So equals average select data. Oops, hold on, see? Mistakes are made. That's because I have B30 in there. So let's edit. Oop. You know what? When in doubt, start over. So we have equals. See? Even we make mistakes. Let's try this again. Okay, fixed my typing error. Okay, so let's go back. Equals average. Type it in, pops up, click it. Now we need to tell it where the data is. Make sure that you're selecting just the data you need. Enter. There's my average for 1 kp for column number 1. Now, I'm going to do the same thing for standard deviation. Click it. Nope. My mouse pad is a little sensitive, so make sure I get the data I need. Again, participant 1 through 11, enter. Now, for the quick and easy way to get all of your data on here, for mean, make sure you're selecting the column that you first did the calculation in, and then drag that, highlight that all the way to the end, to minute 15. We go to fill, right, boom, there it is. There's all of our data that we need, and we're not doing mean and standard deviation on, or typing it in on everyone. We're going to do the same thing for standard deviation, fill right, and there it is. So we want to do this first because we always need to look at mean and standard deviation, right? And that's what you guys are doing repeatedly in this lab, and every lab report we have you do. So the best thing to do is just get all of this done. Oops. ST. Standard deviation. Going to highlight what I need, enter, fill, right. And same thing for standard deviation, fill right. Okay, so now I have all my means and standard deviations. All right, so now that I've calculated the means and standard deviations for all three workloads for rest, exercise, and recovery, now I'm going to move on to results number 2. And in results number 2, I need a figure 1, which is going to be a scatter plot. And I'm going to plot the mean oxygen uptake plus or minus the standard deviation versus time for all three exercise conditions. So we're going to include data for rest, exercise, and recovery. We need titles on all our figures and all our tables. We're going to need a title, but you want to put figure 1, title, and a descriptive figure legend. We need to know what we're looking at when we're looking at your lab reports. So let's go back to the data, and we are going to graph mean for all three workloads. Now, we don't graph standard deviation. Oops, wrong button. We don't graph standard deviation in a line. It is what we call an error bar. And we will do that in 1 second. So you can see, sometimes things are hard to grab. So it's good that you're seeing me struggle with these mouse bar. All right, so I got all that up. I got all that highlighted, I should say. And now I'm going to do a scatter plot. So I need to go to Insert. I'm going to go over to my graphs. Where is my scatter plot? Scatter plot, here you are. Scatter plot. Let's do a scatter plot with some smooth lines. All right, so do I have 4 lines. What am I looking at? Okay, so I had some issues with making my chart, but I got it to work. So if you're having trouble making a line graph or a scatter plot graph like this, the best thing I can tell you to do is I would select my x-axis and I would select one y-axis. Like I was trying to do it multiple, which in reality I should be able to do, but my Excel's funky. And what may happen is you may have the same problem. So I'm going to show you the little trick I did to make it work for myself. So you can see I highlighted my x, I highlighted one y, and I want to try to make it so all of the y's are in this chart, but this is the way I had to do it. And if you ever have trouble and you're like, I can't make this work, just go back to this video and watch what I did. So I'm going to pick a scatter plot, but I do want some lines through my chart. So you can see it's graphed exactly the data I wanted it to. It did minute on the bottom, it did my means on the y, and it gives me my nice little graph that I want. So in order to add another line, there are ways you can do it, and there's sometimes Excel lets you do it the simple way, which is highlight everything that you want to graph and click graph, and it will do that. Mine wasn't doing that. So what I found is my workaround is if I put my cursor on the graph and I right click and I go to select data, I get this data source. And what I need to do is add the other 2 workloads. So here I'm going to click on add. Yours may look a little different. If you have a Mac, it will look different. If you're in a PC, it will look different. They all have this select data function though. So under X value for series 2, I'm going to do the same thing. I'm going to highlight my minutes, and it's there. And then under Y value, I'm going to highlight my mean. There we go. I'm highlighting my mean, and it's there, and I click OK, and it's added my second line. And then I just do the same for the third. Again, it's not always the most efficient way, but when we have issues with Excel, or there's millions of I'm totally way ahead of myself. There's millions of versions of Excel. What we end up having to do is figure out what is it doing with our computer. And I figured out what it was doing with mine. So you saw me struggle. Pause the video, figured it out. So here we are. I'm doing my third line. I go to X, highlight the minute. I go to the Y, I highlight my mean. So for some reason my Excel needed everything told to it piece by piece. And there we go. So now I showed you how I did it. I'm going to delete this one now because I've already have it up. Alright, so this would be my figure 1. I need to put my title, I need to put figure 1, and I can't spell. I need to put my title, which could be, what am I looking at? So when we're asking you to put a title, it's just saying like, what is the viewer looking at? So if I was to look at this graph, I'd be looking at probably oxygen consumption at different workloads. And well, let me back up. We're looking at oxygen consumption at rest, different workloads, and recovery. So that could be what I put in for my title: oxygen consumption at rest, varying workloads, and recovery. You're just telling the viewer what are they looking at. And then I'm going to want to make sure that these lines are named down here. So you could do the same thing I did to get the data in there, is go to select data, and each one of these series you can name. So series 1 is 14, so that's here. That's my 0.5 workload, so I can put 0.5. And then my series 2 is probably my 1.0. And if you don't know what I'm looking at this 4.6, and I'm going down here to see what 4.6 is. So that is my 2.52. I guess it's 2.5. It says 2.5 right here. I'm just going to put it as 2 because I'm not sure. Put units. I didn't put that on the first one, but put units. And this would be my 1.0 KP. And then I'm going to go back up here and I'm going to put my KP in. Units are so helpful. If you can put units in anywhere and everywhere, that is exactly what you should be doing. Okay, so this is my figure 1. I will put my title in. I'll put figure 1 in my title. I will label the line so the viewer of your paper, meaning me, Mendoza, or in a way, actually know what we're looking at. Alright, so then number 3 under results is calculating mean and standard deviation for gross efficiency, net efficiency, and O2 det for all 3 workloads. And we're going to put this in a table. So on our data sheet, if we scroll over, there it is. I'm just going to move this out of my way. So I'm going to say mean, standard deviation, and I have my workloads. I have gross efficiency for all 3 workloads. I have net efficiency for all 3 workloads, and epoch for all 3 workloads. Okay, so same thing we did on the opposite side. We're going to look for average, click it, highlight our values, enter, Same thing with standard deviation. Get it on there. Get it on there once. We're going to fill right. Same thing for standard deviation. We're going to fill right. Okay, so we're asking you, let's pull this back up, to make a table of the means and standard deviation of efficiency gross, efficiency net, and O2 debt for each workload. So you're going to make a table out of that. I'm not going to, you guys should know how to make a table by now, but everything you need is right here. And I just realized, hopefully you caught my mistake, is I did not put standard deviation on my chart. So let's go back a step. So let's go back to figure 1, and we're going to put our standard deviations on this chart. All right, so now we're going to add the error bars, and I was just making sure on my computer, it is a Mac, how to find the error bar option. It's, I think on the PC, if I remember from the PCs in the lab, it's roughly the same way. So what I want to do is I want to click on the line I'm going to add my standard deviation to, and it will highlight, as it did here, which one I'm looking at. Let me just double check this. All right, so I have all my dots are highlighted, and I did that just by clicking on the line. It's showing me where those means are, so then I know where my standard deviation is. And on the top, you'll see chart design and format. When you click inside the chart, those two things will pop up. So once chart design is selected, I'll go to add chart element, and I'm going to go to error bars. And I want to go to more error bar options. And what it just did was it added a standard fixed value, and you can see that over here. But I want to tell it what the values are going to be. So I'm going to click on custom, and then I'm going to highlight my standard deviation numbers. I'm going to click OK, and it will add those bars, and sometimes it will add some horizontals. I just want vertical. I'm not going to worry about that right now. So I'm going to do the same thing for my last line and make sure it's highlighted, add chart element, error bars, more error bar options. Again, it's going to give you a fixed value. You don't want that. You go to custom, click on specify value. These are the standard deviations I want to add. I'm going to click OK, and my chart's really tiny, so let's make it a little bigger so we can see what's happening on here. And you can see it's added the error bars. If it's adding some horizontal ones, I try to delete those. Sometimes Excel is funny. When you're in this format chart area and you have that error, let me try to select one. You can see right here, it'll say vertical error bar. If you're getting horizontal bars, it's because this right here, where it says vertical, will say horizontal. What I do to get out of that is I just restart the whole standard deviation process. All right, so now we have our chart, our figure 1 with all our means and standard deviations. And we did our table, which you guys will do your table of the different workloads, the mean and standard deviation at the different workloads for gross efficiency, net efficiency, and oxygen debt, okay? So those are your first 3 things you're going to do. So we've done We've calculated mean standard deviation. We did our figure 1 and we calculated our mean standard deviation, and you guys will put that in a table, calling that table 1. Next thing we're going to do is do 3 ANOVAs. A one-way ANOVA to compare each workload for gross efficiency, a one-way ANOVA to do net efficiency, and a one-way ANOVA to do O2 dead. So let's move back to Excel, and we're going to do a one-way ANOVA for all 3 of these workloads looking at gross efficiency. So we're going to go to Data, Data Analyze, Data Analysis. I'm going to go to my single factor ANOVA, and it wants to know what's the data range. So I'm going to pick gross efficiency for my 11 subjects, and I highlighted let me just do that again. I highlighted the title, okay? But if you want to get really technical, which I think is a good thing to do, you can put 0.05 kp in the title for the first one. You can put 1 kp in the second. So then you can know which of the different workloads is. And then I am going to put 2 kp in the title of that one. Okay, so now I'll go back to data analysis, single factor ANOVA. I am going to highlight those first 3 columns, and I'm going to tell Excel that my labels are in my first row. And what I should come up with are 11 subjects, okay? So here I go. I'm going to click OK. Boo, there it is. There is my ANOVA. Okay, so here's my ANOVA, and I just want to hold on, I'm trying to expand this out so I can see the whole thing, but let's do it this way. All right, so what am I looking for? So here's my single factor ANOVA. I am looking for my p-value. Here's my p-value. I have that, and we'll go over that in a second. The other important thing I want to make sure is that this count is 11, okay? If this count is not 11, you probably didn't click the labels in first row, okay? So I want my labels there. If I did not click labels in first row, I would have 12. So it's important to double check that stuff, okay? So my my count is 11. And my p-value has to be less than 0.05. This is less than 0.05, okay? This E tells me the exponent is minus 15. So you have 15 places you're going over with that 0.00000. If you see an E in here, it is, I always say E is extremely not negative, but I think it's a good thing, right? Because it's telling me that the exponent is really over there. So I know that this value here is telling me that my single factor ANOVA is significant. So what you'll take is this data here, you're going to copy it and paste it in a Word doc, and this is what you're going to show us, okay? You're going to say that in a single factor ANOVA, gross efficiency for all 3 workloads, at all 3 workloads is significant. There is a significant difference between the 3 workloads for gross efficiency. That is all you're stating, okay? You can't tell me how significant it is. It can't be really significant or less significant. It can be significant or not. And this is telling us that it is significant. And you're going to do the same thing for net efficiency. So let's just run that 0.5 kp. Again, put as much information in these little title boxes as you can. 1 kp, 2 kp, and we're going to do our ANOVA. Data analysis, ANOVA single factor. It wants to know the data. What is the data range? And I am going to tell it. It's these 11 subjects with the label in the first row. Okay, here, I have a snoring dog next to me, so just FYI. She's so loud. Here's our p-value. Okay, I have my 11. I have net efficiency and I have 11 count. My p-value is significant. Again, net efficiency at different workloads is significant. Okay, just remember that. That's all you can state. All right, and then you'll do the same thing for oxygen debt. So you don't need me to do that. You guys should be experts at this point. That is oxygen debt. All right, so we have done our means and standard deviations. We have made our figure. We have made our table. We have run our ANOVAs. You're going to present your ANOVAs in a table. It will be table 2 for gross efficiency, table 3 for net efficiency, and table 4 for O2 debt. So you're just going to make separate tables of what we just ran right here. Review all data from your experiment, and in a sentence or two, summarize the main findings of this lab. So this is going to be in the opening section of the results section. You're going to have your purpose. It'll say purpose statement. Then you're going to have results, and you're going to have your 1 or 2 sentences summarizing what you have found in this lab. And then you're going to have figure 1, table 1 through 4, okay? And then under each table and figure, you're going to tell the viewer what they're seeing. What was the end result? What is this showing them? So you have your descriptive title, but then you want to just tell them in a sentence, what is this figure or table telling them? That's all you're doing, okay? So then the results summary for all four tables in one figure. You're telling, again, what is this telling the person? And then in your discussion, you're going to answer the following questions. So it's going to have, you're going to talk about, do your results show a difference between oxygen consumed at the different workloads, which will be your figure 1. Explain results using what you know of the physiological process. This is where you get to show off what you're learning in this class. Is there a difference in gross efficiency, net efficiency, and O2 debt at the different workloads? So that's your table 1. Is there a statistical difference? So you're going to be discussing this more in depth. The result summary is basically just saying, this is what I see. The discussion is, this is why it is presented, why the data is coming out the way it is coming out, okay? It is explaining, answering the question for your reader, so they don't have to go do the study. They can read your lab report and be like, oh, that is why this is happening. You're going to write a concluding paragraph summarizing your results, and then any reference you use put in APA format. So your paper, your lab report should basically be laid out the same way this sheet is. You'll have purpose, you'll have your name, lab report 3, purpose, boom, purpose statement, results. You'll have your different figure table. So I would jump from purpose here and then results, okay? After you run this is how your paper should be set up. Results summary, figure 1 with your figure 1, and then your couple sentences describing what we're seeing. Table 2, have the title, describe what we're seeing. The same for the other tables. And then in your discussion, you are explaining what you found, okay? And then you're writing a concluding paragraph for that. We're going to put, well, we'll be here, Mendoza, Inouye, and I, to help you with this stuff. I am telling my lab Wednesday morning, please don't worry about this too much until after you take your lab exam. This is not due for another, well, a week from next week. So everyone has their lab exam next week. Please study for that. And I have a video up on the website that I did for I'm going to find it here, for Wednesday night's lab. Here it is. It's an oxygen efficiency video. I go through all the calculations. Please, if you're having trouble with the calculations, please view this video and ask us questions before your exam. All right? Hopefully this is helpful. Thanks, guys.